7th graders, welcome to our new unit. To kick this unit off, we're going to do this activity called Exploring Trophic Cascades. A lot about what you guys learn in this lesson is going to be something that we use throughout this whole unit. So you guys are kind of getting a little sample of everything we're going to learn in this unit. Okay, your learning targets. I can start to determine how populations in an ecosystem influence each other, so I can predict what would happen if one population changes. And I can determine direct and indirect effects and positive and negative relationships between organisms in an ecosystem. So you guys are going to start to take a look at food webs and how energy is transferred through an ecosystem with different populations of an organisms and kind of say, hey, if this population eats this population, is that going to be a positive effect or a negative effect? And if we remove this population from our ecosystem entirely, how does that affect the other organisms? So you guys will take a look at that. Okay. Your bell ringer for today. If one population of organisms in an ecosystem changes sizes, do you think it could have an effect on other organisms in the ecosystem? So you guys will circle yes or no. Okay, if we take one group of organisms out of an ecosystem, do you think it's going to do anything to the other organisms there? Yes or no? And then explain why or why not. If you need, use an example to help you. Okay, so go ahead, take a second, pause this video, finish up your guys' bell ringer, and when you're ready, we'll move on. All right, on slide 3, you guys have the link of the website we're using today. So go ahead, right-click that and open it up. And you guys are going to see a website that looks like this. So the very first thing we're going to do is work through our introduction. So let's go ahead and do that together. So we're going to click Introduction. Ecosystems are comprised of a community of organisms and their physical environment. So when we talk about an ecosystem, we're talking about all the living things, but also all the non-living things, because we wouldn't see animals that aren't adapted to that environment in that environment. Okay, so that's really important that we consider both their environment and the different organisms that live there and how they're adapted. Ecologists study the interactions among these organisms and the factors that affect organisms' distribution. The structure of an ecosystem can be represented by a pyramid made up of trophic levels, such that producers are on the bottom. So producers are anything that can make their own food, like plants. Okay. Primary consumers right above them, so they eat only plants. A lot of those are considered to be herbivores. And then secondary consumers can eat both plants and animals, those kinds of things. So all on up to our apex predators. Okay, this click and learn illustrates examples of what can happen when the top of the pyramid changes. How are the levels below affected? How does the ecosystem change? So we're going to look at all kinds of changes that we see in ecosystems throughout this whole unit. This is just one example. A classic study that illustrated how predators control the organization of an ecosystem was done by ecologist James Estes, who examined what happened to ecosystems when the sea otters were hunted to near extinction in the Pacific Northeast Ocean. So you guys will go ahead, navigate to this page, and I want you guys to pause my video for a second and take a second to watch this short video about sea otters in the ocean off the Northeast and the Pacific. Okay, so pause and watch this. When you guys are done, come back to this video. Okay, moving forward, we're going to use this example of sea kelp and sea otters to kind of see how if the sea otters are hunted to extinction, what happens to the other organisms in that ecosystem. So this video introduces the concepts of direct and indirect effects. Continue the click and learn to explore more and see how the disturbances to one trophic level of an ecosystem are transmitted to other levels. When we talk trophic level, I want you guys to know that the Latin root word troph, T-R-O-P-H, means energy. So if we're talking about trophic levels, is how are these levels of getting energy? So, you know, the primary consumers eat the producers, so they get their energy from the producers, those kinds of things. So it's just kind of a big food web. Okay, let's go ahead and click on our kelp example. Okay, next part says, click on kelp example at the top. Work through pages 1 through 4 and answer the questions on the next slide. So just work through 1 through 4. Don't go on to slide 5 or page 5 yet. You guys can kind of see what page you're on right here. I'll move this little guy. Okay, so right now we're on page 1 of 3. So we're just going to work through page 4 right now. Okay, so we've got the sea otters, we've got the urchins, and the kelp. Those are 3 of many organisms in this ecosystem, but they're the 3 main ones we're going to focus on for now. So in order to track changes in an ecosystem, let's look at how members of the community affect each other in a simple system. So I want you guys to go ahead and take it from here. I want you guys to work through just pages 1 through 4. Okay, so click through, read what it means. You guys can click the next, read what that means, and then you guys will answer these questions. Again, we're on page 3 already right now, so you guys are just going to work through page 4. Okay. All right. So your questions that you need to answer as you work through pages 1 through 4. What does the negative symbol on the diagram mean? What does the solid arrow or solid line mean? What do sea otters eat and what do urchins eat? So you guys are just working through those. And then what happened to sea otters during the 1800s? And predict, what do you think happened in that ecosystem when the sea otter population changed? So how do you think that ecosystem was affected when we changed the number of sea otters? Okay, so think about what happened to the sea otters in the 1800s. And knowing what you guys know about that little food web that you guys just saw of how organisms eat or feed off of other organisms for energy, how do you think that might affect the other two populations that we're looking at, mainly the sea urchin and the kelp? So again, just work through slide 4 right now. Pause this video, finish up slide 7, and then when you're ready, we'll move on to page 5 of our little simulation. Okay, now move on to page 5 to see what happened to the ecosystem after the sea otters were removed from the ecosystem. So let's see if your prediction was actually correct. Work through just page 7. So again, we should be starting on page 5 right now, and we're just going to work through page 7. So I'm going to let you guys go ahead and do that on your own. Okay, and then answer the questions on the following slide. So this is the questions you guys are answering. What happened to the sea urchin populations when the sea otters were nearly hunted to extinction? So what actually happened to the sea urchins? Okay, what happened to the kelp population when the sea otters were nearly hunted to extinction? So take a look at what happened to the kelp. Okay, what does the dashed arrow mean and what does the plus symbol mean? Okay, go ahead, take a second, pause this video. You guys are working through page 7, okay, and just through slide 10 on your PowerPoint. Again, when you're done with those, come on back to this video. All right, on the next slide, draw arrows, dashed or solid, and symbols, positive or negative, to show the relationship of organisms in this food web and show what happened when the sea otters were hunted to extinction. Okay, so on the next slide, we have this little map for you guys, and this is similar to what you guys saw in the link, so go ahead and draw your arrows to connect these, label whether they're positive or negative, and then show me indirect and direct effects. So are they solid arrows or are they dashed arrows? So you guys will go ahead and illustrate with the draw tool on slide 12. Pause this video to do that. When you guys are done with slide 12, we'll move on to our final parts of our kelp example. Okay, all right, now moving on to page 8. Okay, the real ecosystem is much more complex than just these 3 organisms. So you guys are going to take a second to learn about seagulls, basically, and bald eagles, and how the change in the sea otter affected those 2 organisms as well. So move on to page 8, finish the kelp example, and answer the following questions. So first thing you're going to look at is the glaucous-winged gull. What do the gulls primarily consume? So what's their main source of food? And then what happened to their diet with the gulls when the otter disappeared? So they had a specific diet that you guys just told me about. What did they have to eat after that? What happened to their diet when the otters disappeared? Okay, and then for bald eagles, what do the bald eagles specialize in eating? So what's their main thing that they're good at eating? And then what else can they eat? So that's not the only food item they have, so what else can they eat? What happened to their diet when the otters disappeared? So what happened when those otters disappeared to the eagle's diet? Okay, go ahead, take a second, pause this video. You guys are going to work through slide 15 in your PowerPoint. You're going to go ahead and finish up through page 13 on your link. Okay, that's going to conclude our kelp example, and then we'll move on to the case studies together. So pause, finish that up, and then we'll move forward. All right, to close this assignment out, you guys are going to take a look at a couple different case studies, 2 to be specific, and then I'm going to do 1 for you guys. So technically, you'll go through 3 of these examples. So click on the case studies at the top. We will be working through 1 example together, and then you guys will complete 2 on your own. For the example, click on African Savanna. So African Savanna is one of the more complex ones, so I'm going to kind of work through it on this one with you guys, and then you guys will fill out this data table with me. Then you guys will take a look at the Venezuelan jungle and answer the questions on it, and the Arctic tundra and answer the question on that, and then you guys are done for today. So let's go ahead and take a look at our African savanna. So I'm going to click on case studies. I'm going to choose African savanna, and we're going to learn about this little virus that infects wildebeest. So not every predator is physically large. Diseases can also shape communities through trophic cascades. Rinderpest is a virus that affects cattle and large herbivores in Africa. Affected animals have a high mortality rate, meaning that they die a lot. When the government instituted a rinderpest vaccination program, sweeping changes took place in the environment. And we're not going to focus too much on that so much as just what happens when rinderpest comes into an ecosystem. So when the government instituted a rinderpest vaccination program, sweeping changes took place in the environment. Does rinderpest have a positive or negative effect on the wildebeest? So what you guys are going to do is you're going to go through and click. We know that rinderpest is a virus that infects wildebeest and kills them. So this would be a negative effect. So I would click the negative, and then I can see that I'm correct. Correct, rinderpest is a virus that actually causes high mortality in grazing ungulates, excuse me. So it has a negative effect on the wildebeest. Okay, the wildebeest eat the grass. So the wildebeest are going to lower the grass population. It's not good for the vegetation. So correct, wildebeest are both grazers. So an increase in the wildebeest population results in decreased vegetation. Okay, the vegetation. Okay, if we have more vegetation, we would have more fire. So if we have less vegetation, we have less fire. So I'm going to go ahead and say that that's going to be a positive effect. We're going to have more fire if we have more vegetation. So correct, the likelihood of fire is greater with a greater amount of vegetation. So I've gone through and kind of highlighted and said, all right, this has a negative effect, positive effect. Okay, so we would look at this and say, all right, is this positive or negative? The rinderpest to the wildebeest is negative. Okay, the wildebeest to the vegetation, negative. And the vegetation to the fire is going to be positive, so I would mark that in here. And then last but not least, we have this. So these are all solid arrows, so these would all be direct effects. So I would put direct in all of these. Okay, I'm just going to copy and paste. Okay, and then let's take a look at the rinderpest and the fire. So if we have more rinderpest, we're going to have less wildebeest. If we have less wildebeest, we're going to have more grass. And if we have more grass, we're going to have more fire. So rinderpest means that we're going to have more fires. Okay, so with that being said, this would be a positive thing for the fires. So rinderpest to fires is a positive, but that's going to be indirect because the rinderpest only directly affects the wildebeest, not the actual fire itself, as a virus can infect a fire. Okay, so this is how we would fill out that table. Okay, then you guys on the other two have a question to answer. I don't have a question for you guys to answer on this one. So that's just kind of how you guys fill out the table. So again, you guys will go through this. I'm just going to get this done with. Oops. Okay, so, oh boy, sorry. What? Okay. Well, let me go on. Okay. So now if I go back to my case studies, you guys are going to look first at the Venezuelan jungle. So you guys are going to look at predators, herbivores, and it's not wanting to load right now for me. Okay, so predators, herbivores, and then your vegetation here. So you guys will go through that cascade and see how they affect each other, whether it's direct or indirect, and whether it's positive or negative. And then having those large predators. So do large predators have a positive or negative effect on herbivores? Choose plus or minus. So the whole premise behind this is a dam project in Venezuela created small isolated islands lacking large predators. So if we were to get rid of those predators, what happens to our vegetation in this trophic cascade? Okay. So carnivores to vegetation is going to be your guys' final one that you look at that you're going to have to think about. Is that direct or indirect? And is it going to have a positive or negative effect? And you'll answer this question. What effect do predators have on the jungle ecosystem? So if we don't have them, what effect does it have? Okay. For the Arctic tundra, do foxes have a positive or negative effect on seabirds? So in addition to controlling the relative amount of primary productivity, trophic cascades can also change the landscape by altering the movement of nutrients through the community. So think about this one and what the community would look like. In this example, the introduction of Arctic foxes had effects beyond the birds that they eat. So we are looking down to the amount of grass that these two communities have based on the amount of foxes. Obviously, foxes don't eat grass. Okay, so is that going to be a direct or negative effect, or excuse me, direct or indirect effect? And then what effects are we going to see throughout our other ecosystem, our trophic cascade? So go ahead, fill out this table, positive or negative, direct or indirect, and then answer this question. What happened to the Arctic landscape when the foxes were introduced? What changed? Okay, and then finally, do your guys' wrap up. How do you feel? Do you have any questions? Yes or no? If you do, type them there. If not, leave it blank. And then 4, 3, 2, 1. Go ahead and circle that. You ought to turn this in. Good work. I hope you guys have a great day, and I will talk to you soon.